All right, welcome. We are about to walk through one of the most critical topics in all of AWS, network security. We're going to look at the two fundamental tools you have at your disposal to control every single packet that flows through your cloud infrastructure. You ready to architect a secure network? Let's dive in. So, this is the big question, right? It's the one every single cloud architect has to answer. It's not just about letting the good traffic in. It's about building a fortress that knows exactly what to block, ensuring your applications can talk to each other securely, and, just as importantly, efficiently. Getting this right is the absolute cornerstone of a well-built cloud environment. Here's how we're going to break it down. First, we'll look at the two layers of defense AWS gives you. Then, we'll do a deep dive into security groups, and after that, network ACLs. We'll put them head-to-head to see how they stack up, and then we'll pull it all together to build a complete, layered security architecture. I want you to think about AWS network security as having two different guards on duty. They're on the same team, but they have completely different jobs. One is like a personal bodyguard assigned to a specific asset. The other is like a guard patrolling the big wall around the entire compound. And this separation of duties is really the key. Security groups give you that micro-control. They're the personal bodyguard for your EC2 instance. Network ACLs, on the other hand, provide macro-control. They're the big wall around the whole neighborhood, or, in our case, the subnet. So let's start from the inside out and meet our instance guardian. Okay, let's talk about our first component, the security group, or SG for short. The best way to picture an SG is as a virtual firewall that is literally attached to your resources network interface, like an EC2 instance. It is your first and most important line of defense. You know, the real magic of security groups comes from this combination of features. They operate right at the instance level, and they are stateful. We'll get to what that means in just a second. But this is the critical piece. By default, they deny all inbound traffic. It's a secure by default model. You can only create allow rules, which forces you to be very explicit about what you're letting in. This makes them perfect for creating those precise zero-trust access policies. So what does stateful actually mean? Well, think of it like a conversation. A stateful firewall remembers the connection. If you create a rule to allow your friend to knock on your front door, the firewall automatically knows to let them leave through the same door. You don't need a second rule for the exit. It dramatically simplifies things. Now, this right here is the absolute game changer for security groups. It's the ability to reference other security groups as your source, instead of hard-coding IP addresses. This lets you build an incredibly secure multi-tier architecture. Look at this. The app server only trusts traffic from the web server group, and the database only trusts traffic from the app server group. This is a true zero-trust model, and it's dynamic. You can add or remove web servers, and you never have to touch the app server's security rules. It's brilliant. Okay, so let's zoom out. We've secured the instance. Now let's look at the broader perimeter, the subnet. And this is where our second guard, the network ACL, or NAC, comes into play. A NAC applies its rules to every single thing inside an entire subnet. And as we go through the features here, you're going to see it's a totally different beast from a security group. NACLs are at the subnet level, and they are stateless. And look at this default rule. It's allow all, the complete opposite of a security group. Plus, you can create both allow and deny rules, and they get processed in order based on a rule number you assign. Now, this is the critical piece about NACLs you have to understand. They are stateless. Think of it as a bouncer at a one-way door. If you create a rule to let someone in, the NACL immediately forgets about them. For them to get back out, you have to create a completely separate outbound rule. This lack of memory adds a ton of complexity. And because of this stateless nature, you run into some real headaches. You can't reference security groups. You're stuck using IP addresses. That need for both inbound and outbound rules is a huge source of errors. For example, if your server needs to make a request to the internet, you need an outbound rule to allow it. But you also need an inbound rule to allow the response to come back in. And that response comes back on a high-numbered, unpredictable port. Get that wrong, and your application just breaks. Honestly, this complexity is why most people only use NACLs as a blunt instrument to block known bad IP addresses. Okay, time for the showdown. Let's put these two side by side. Getting these differences straight in your head is absolutely essential for designing a good AWS network. Let's just walk through this. The biggest difference, state. SGs are stateful, NACLs are stateless. Then scope, SGs are tight on the instance itself. NACLs are broad at the subnet boundary. Their default settings are polar opposites. SGs deny everything by default, while NACLs allow everything. And finally, the rules themselves. SGs are an allow list only, while NACLs let you create both allow and deny rules. If you only remember one thing from our time together, please let it be this. This is the critical piece. Security groups are your allow list. You use them to define with surgical precision exactly what traffic is permitted to reach your instances. Network ACLs are your denial list. They are the broad shield you use to block entire ranges of IPs you never, ever want talking to your network. So, how do we use these two tools together to build something really secure? Let's walk through the architecture of a layered fortress, using the principle of defense in depth. This is where every layer backs up the others. A best practice architecture looks something like this. Way out at the edge, you have a web application firewall, or WAF, that's filtering out common attacks. Then, maybe you use something like a gateway load balancer to force all your traffic through a fleet of advanced firewalls for deep inspection. And then you get to our two layers. Your security groups apply those super specific zero trust rules right on the instance. And finally, acting as your outermost wall, the network ACL is there to block known malicious IPs before they even get close. That is how you build a real digital fortress. So as we've seen, security groups and network ACLs aren't fighting for the same job. They are partners. One is a scalpel for precision, the other is a shield for broad protection. When you master how to use them together, that's when you can build truly secure, scalable, and resilient applications on AWS. So now you have the blueprint. The question is, what will you build?